Hey guys, this is a video on topics 2 and 3, focused on finding area and perimeter of dilated figures. So in this diagram, I have triangle DEF is the image of triangle ABC after a dilation. So that tells me that triangle DEF is the new triangle, and triangle ABC is the old triangle. I'm just going to label those right inside the triangle so that we can easily remember that. So in order to find a new area or a new perimeter, we need to find the scale factor of the side lengths. So every single time we want to find a scale factor, we set up new over old. That's what a scale factor is. So in this case, my new triangle is triangle DEF. My old triangle is triangle ABC. So if I set up my scale factors, I have DE over AB equals EF over BC equals FD over CA. Now I know because a dilation happened, these are equal to each other. I don't have to find all three, I only have to find one of them. So I'm just going to pick one. DE has a length of 8. AB has a length of 4. So my scale factor is equal to 2. Okay, I know this scale factor will be equal to 2. And this scale factor will be equal to 2. We can check that really quick if you're not convinced. EF is 6 over BC is 3. 6 divided by 3 is 2. DF is 10 over AC is 5. 10 divided by 5 is 2. So my scale factor for sides is 2. Now, you guys need to understand what a scale factor is. A scale factor is whatever number we multiply to get from an old side to a new side. So to get from 3 to 6, we multiply by 2. From 4 to 8, we multiply by 2. To get from 5 to 10, we multiply by 2. That's what a scale factor is. So when I need to find a new side length, I know that I can do a new side is equal to an old side times the scale factor. Okay, that's what I just did. Old side, 3, times 2 is the new side. Old side 4 times 2 is the new side, so on. Now guys, this is, again, like this is what a scale factor is. If I were to solve for the scale factor here and divide this side by the old side length and divide this side by the old side length, this reduces, and guess what? Your scale factor is equal to new over old. That's where that comes from. Okay. So now let's talk about area and perimeter. Let's start with the perimeter of triangle ABC. I'm going to do this right up here at the top. So my perimeter of triangle ABC, all I need to do is add up the side lengths. So I have 3 plus 4 plus 5 is 12. Okay. Perimeter of triangle DEF, I'm going to add up the side lengths. 8 and 10 is 18 plus 6 is 24. Okay? So again, we want to know what the relationship is between the old perimeter and the new perimeter. Well, if I take the old perimeter, 12, and multiply by my scale factor 2, I'm going to get my new scale factor, or my new perimeter of 24. So my sides and my perimeters are in proportion because they have equal scale factors. So if I know my old, if I want to find my new perimeter, I know that I'm going to multiply my old perimeter by my scale factor. So again, in this example, 12 times my scale factor of 2 gives me my new perimeter of 24. So all I need to know is my old perimeter and a scale factor, and you guys know how to set up scale factors. Okay, let's do area. So my area of triangle ABC is, remember, area is 1/2 base times height. These are right triangles, so my base and my height are 3 and 4. So I have 4 times 3 is 12. Half of that is 6. My area of triangle DEF is 1/2. My base and my height are 8 and 6. So my area is 24. Alright, so my relationship doesn't hold here. 6 times 2, my scale factor for sides, is not 24. So area does not have the same scale factor as size. I cannot just multiply by the size scale factor to get the new area. So what I have to multiply by is my scale factor squared. So if I want to find a new area, I multiply my old area, not by just my scale factor, but my scale factor squared. In this case, my scale factor is 2, so 2 squared is 4. If I multiply my old area 6 times 4, I get my new area of 24. Okay, let's look at this one quickly as an example. I have triangle XYZ is the image of triangle ABC. That means triangle XYZ is my new triangle, it's the image. Triangle ABC is the old triangle. I give you some side lengths, and I give you the perimeter of your old triangle. I ask you to find the perimeter of your new triangle. So again, in order to do that, I need a scale factor, and I set up scale factor the same way every single time. Scale factor is equal to new over old. That's triangle XYZ over triangle ABC. Set up my scale factors. And substitute what I know. I know AB is equal to 16, and I know XY is equal to 4. So if I reduce in my calculator, 4 divided by 16 is equal to 1/4. That's my scale factor. But I don't even have to reduce. I can use this. This is the same scale factor. 1/4 is equivalent to 4 over 16, so it doesn't matter which one of these I use. So now I want to find my new perimeter. It's equal to my old perimeter times my scale factor. My old perimeter is 40 times my scale factor of 1/4 gives me a new perimeter, which is, by the way, the perimeter of triangle XYZ. 40 times 1/4 is equal to 10. That's my new perimeter. Okay, that makes sense because if my scale factor is 1/4, my figure is getting smaller, so my perimeter should be small. My new perimeter should be smaller. All right, let's try area. Again, I give you the area of the old triangle, ask you to find the area of the new triangle. This is X. Okay, I still need to know my scale factor. My new area is equal to my old area times my scale factor squared. So if my old area is 128 and my scale factor is 1/4 squared, then my area of triangle XYZ, that's my new triangle, is equal to 128 times, in parentheses, 1/4 squared. So that looks like this in our calculator. 128 times 1/4 squared, and that 1/4 is in parentheses. And I get that my new area is 8. Again, that makes sense. My area should be getting smaller.